So for today's video, we need to calculate this problem. So according to problem 111, for the truss shown in figure P111, calculate the stresses in members CE, DE, and DF. The cross-sectional area of each member is 1.8 inches squared. Indicate tension or compression. So to get the value of the stresses CE, DE, and DF, we need to find first the reactions acting on this figure. So first, let's have the moment of A, which is equals to 0, to get the value or the reaction acting at F. So RF times 24, which is equals to 30 clockwise times 16. Therefore, RF is equals to 20 kips. So to solve the value of CE, we need to start the section here and consider right. So from the previous equation, the reaction at F is equals to 20 kips. So as you notice, these are the reactions na mag-activate, which are the members BD, members CE, and member BE. So let's assume that the direction of member BE is tension, while compression for members BD and members CE. So to get the value of CE, we need to find first the moment at B. So the summation at the moment of B is equals to 0, wherein mawawala yung members BD and BE, and mag-activate na lang is yung member CE. On the other hand, the ratio for this triangle is 3, 4, and 5. So if we extend the value at point C, then we can put the component of C here. So this is CEX, and this one is CEY. So the moment at P is 30 because it is clockwise, multiplied by 8 minus 20 because it is counterclockwise, multiplied by 16. And the component of CE is equals to 4 over 5, that is counterclockwise, multiplied by the distance, which is equals to 6 feet. Therefore, 4 times 6 over 5 multiplied to CE is equals to 240 minus 320. So CE is equals to negative 80, then cross multiply. So this is over 5 over 24. Therefore, the value of CE is equals to negative 16.67 kips, which is tension. So the stress at CE is going to be 16.67 over 1.8, and that is equals to 9.26 kips over inches squared, or 9.26 KSI, which is also equals to 9,260 PSI. Then to get the value of EF, we need to start first at joint F. So this is the free body diagram at joint F, assuming that the value of DF is compression and the value of EF is tension. And remember that the member DF has an angle of 3, 4, and 5. Therefore, the summation of forces vertical is equals to 0, wherein the value for the summation of VF is equals to 3 over 5 DF equals 20. Therefore, DF is equals to 33.33 kips or kilopounds. Then to calculate the stress at TF, so the stress of TF is equals to 33.33 over 1.8 is equals to 18.5 KSI. And again, the value of TF is in compression. Next, we need to consider joint E to get the value of DE. So at this free body diagram, let's assume that the value of member CE is in tension, which is equals to 16.67, and tension for member DE. Therefore, summation of forces vertical is equals to 0. So DE is equals to 30, which is going down, plus the vertical component of CE is 3 over 5 multiplied by 16.67. Therefore, DE is equals to 40 kips, which is in tension. And to solve the stress at member DE is equals to 40 kips over 1.8. Therefore, the stress DE is equals to 22.22 KSI. Okay, so these are the answers for the stresses CE, stresses DE, and stress DF. The stress for CE is tension, the stress for DF is compression, and the stress DE is in tension. So this is how we evaluate the actual stress on member.